All right, let's dive in. Today, we're talking about a real powerhouse in the world of adhesives, the 3M Scotch Weld DP420 epoxy. This isn't your everyday glue. We're going to break down what makes this stuff so incredibly strong, and more importantly, how you can use it to get those professional-grade results safely. So, let's get right to it.
So let me ask you something. What if you could ditch welding, rivets, and screws altogether? Imagine creating bonds that are just as strong, maybe even stronger, without all the heat, the extra weight, or those weak spots that fasteners can create. You know, in today's world of design and manufacturing, this is a huge deal. It's all about making things lighter, tougher, and just cleaner.
And that, right there, is where this stuff comes in. The DP420 is the modern solution we're talking about. Look, this is a two-part structural adhesive. And let's be clear, we are not talking about glue. This is an engineering tool, plain and simple. It's built for those high-stakes jobs where you absolutely cannot afford for things to fall apart.
Okay, so let's get into the nitty-gritty. What is it exactly? Well, it's a toughened epoxy. That means it's been specially formulated to be super durable and to handle impacts really well. Its whole reason for existing? To take the place of things like screws, rivets, and yeah, even spot welds. I know, that's a pretty bold claim, right? So let's look at the specs and see what's actually backing that up. All right, let's talk numbers, because that's where the real story is. You can talk all day about strength, but the technical specs are where you see the proof. And trust me, this is where the DP420 really stands out from the crowd.
Okay, first up, the headline number, 4,500 psi. Wow, that is its shear strength, the force it can take before things get pulled apart sideways. To give you an idea of what that means, this is the level of performance demanded in aerospace and automotive manufacturing. It is an absolutely massive amount of force holding that bond tight. This number right here is why it can seriously replace traditional fasteners.
Next up, let's talk about time. You get about 20 minutes of what we call work life, or working time. This is your golden window. It's the time you have after you mix the two parts where the epoxy is still workable. So you have plenty of time to get it applied, line up your parts just right, and make those little final tweaks before it begins to set up.
Now, and this is super important, do not mix this up with the full cure time. That 20 minutes is just for assembly. The bond needs a full 24 hours at room temperature to reach its full, mind-blowing strength. You absolutely have to build this waiting period into your project timeline if you want to get anywhere near that 4,500 psi we just talked about.
So here's a quick look at the whole profile. You've got a super simple 2-to-1 mix ratio by volume. Easy. There's that 24-hour cure time we just hammered home. And look at this, a high Shore D hardness. What's that? Well, it's the same scale they use to measure the hardness of a construction hard hat. So yeah, this stuff cures into an incredibly tough solid. And maybe most importantly, it has high impact resistance. This means it's not going to shatter. It's designed to take a hit and absorb shocks and vibrations.
Okay, a product this powerful, it absolutely demands respect. So we have to talk about safety and proper handling. Honestly, getting professional results is only half about the product's strength. The other half is all about how you handle it.
And let's not beat around the bush here. This is the official warning symbol you'll see on the safety data sheet, the SDS. In plain English, it means that before this stuff is cured, it can cause some nasty skin reactions and seriously irritate your eyes. Look, this is pretty standard for epoxies this strong, and it's a clear signal that we need to protect ourselves.
So what kind of protection are we talking about? This right here is the bare minimum. It's completely non-negotiable. You need proper chemical-resistant gloves. The official recommendation is something like polymer laminate or butyl rubber, not just any old pair. You absolutely must wear safety glasses and make sure they have the side shields. And depending on how well ventilated your workspace is, you might even need a respirator. Don't take chances.
And really, this is the golden rule for working with any industrial-grade chemical. Before you even think about popping the cap, read the Safety Data Sheet, or SDS. It's got everything you need to know: how to handle it, how to store it, first aid info, everything. Think of it as your most important instruction manual.
Okay, so we've covered safety. Now let's get back to performance. How do we make sure we actually get that incredible 4,500 psi bond we've been talking about? Well, it all boils down to your technique.
Let's just hammer this point home one more time because it's so critical. On the left, you've got your working time. That's your 20-minute window to get everything assembled. On the right, you have the full cure time, the 24 hours you have to wait for it to get to full strength. Mixing these two up is probably the #1 mistake people make.
If you clamp something for half an hour and think you're good to go, you are going to ruin the bond. Period.
So the actual process is pretty simple when you break it down. Step 1, surface prep. It has got to be clean, it's got to be dry, no grease, no oil, nothing. Step 2, mix the epoxy. Make sure you mix those two parts together really, really well. Step 3, apply it. Just a nice, even layer on one of the surfaces. And step 4, join the parts, clamp them down so they cannot budge, and then, this is the hard part, walk away. Just leave it alone for a full 24 hours.
So why do we do all this? Why go through all the prep and the waiting? Because this is the payoff. This quote from the official description says it all. We're not just talking about raw strength. We're talking about strength that holds up under really tough conditions. Forces trying to peel it apart or shear it sideways in both hot and cold environments. You're creating a bond that's as strong as, or sometimes even stronger than, the actual materials you're joining together.
So to wrap this all up, I'll leave you with a question. Think about the projects you're working on right now, the things you build, the things you fix. Where could a bond with this kind of muscle, this kind of durability, completely change the game for you? Where could it replace an old-school fastener and let you create something even better?